Function notation, evaluating expressions. So what is function notation? So we commonly call functions by letters because function starts with F. It's a common letter to be used to refer to functions. So this part on the left side looks like we have something to solve there, but it really isn't. This is a method of writing substitution. So instead of like numbering expressions, we letter expressions. So we letter this with F, and we might use F, we might use G, we might use H, or different words that start with different letters. So F is a common one because function starts with the letter F. So this left side of the equation is in function notation. It tells us two things. We call the function F, and the variable in the function is X. So this is read F of X. And this X part just means, hey, on the other side of the equation, you're going to see the variable X being used on the right side. So there's nothing to solve on the left side. This is read F of X, where we're lettering the equation, and we are saying what variable is being used. So it doesn't mean we're multiplying like parentheses normally tell you to do. So suppose Mr. Slope Guy was manufacturing calculators and had equations that were used to find his revenue, his cost, his profit. So let's say Mr. Slope Guy had an equation for revenue. Well, he might want to label that R of X because revenue starts with R. Or if he had an equation that talked about cost, he might want to label that C of X. Or profit, which would be your revenue minus your cost, how much money you have coming in versus how much you have going out. Whatever's left is profit. So P of X could be like an equation that represents profit. So we're just using some letters to represent different equations so we know which equation we're specifically talking about. So, and then we have revenue minus cost would equal profit. And that's kind of a handy formula to know. Because you do run into word problems throughout math that are involving profit, and that's just the revenue minus the cost. What's left would be profit. So for an example problem, we have if f of x equals 2x plus 5. So there's nothing to solve at this point. We just have that we have a function we labeled with f, and it uses the variable x. Now we have something to solve. We have f of 6. So f of 6 just means, hey, on the other side of the equal sign, everywhere you see x, replace it with the number 6. So we can do 2 times 6 plus 5. Well, 2 times 6 is 12 plus 5 is 17. So f of 6 equals 17. Or if we had f of 7, well, f of 7 just means everywhere on the right side I see an x, I need to replace it with 7. So I'd have 2 times 7 is 14, plus 5 is 19. So f of 7 equals 19. All right, you guys pause the video here, find g of x, and we're given g of 3. So find g of 3 using g of x equals x squared minus 3. Pause the video here, come back and see how you did. All right, welcome back. So g of 3 means we're going to put 3 in for x. So we have 3 squared. 3 squared is 9. 9 minus 3 is 6. So g of 3 equals 6. So we can also organize the input rule and output rules into a function table. The variable for the domain is called the independent variable because it can be any number. And the variable for the range is called the dependent variable because it depends on the domain. So let's say we have a table like this where we have our inputs, our domain, our x. Then we have our function rule. We have f of x equals 2x plus 1. And then we have our range or our output as f of x. So if we try a domain of, let's say, a domain of 1, so the domain is the input or the x, so then we do f of 1. Well, f of 1 would be 2 times 1, which is 2, plus 1 is 3. So our range or our output or our y is 3. Then we could try a different domain. Let's try 2. Then we could do f of 2. 2 times 2 is 4, plus 1 is 5. So our range or output is 5. And we could continue doing this with more numbers, domain of 3. f of 3 is 2 times 3 is 6, plus 1 is 7. And lastly, we could do a domain of 4, but then f of 4 would be 2 times 4, which is 8, plus 1 is 9. So our domain we could list as 1, 2, 3, and 4. And our range we could list as 3, 5, 7, and 9. All right, you guys, find f of 3 using the functions given. Pause the video here, come back and see how you did. All right, welcome back. So f of 3 would be we would use this formula, the one labeled f. We'd do 2 times 3 plus 4. 2 times 3 is 6. 6 plus 4 is 10. So the f of 1, this f part told us this was the equation we were going to use. We weren't going to use the g1. We were going to use the one labeled f. So f of 3 is 10. Now we'll pause the video here and we'll find g of negative 1. All right, g of negative 1 says we're using this one, 4 times x minus 3. Well, 4 times negative 1 is negative 4, minus 3 is negative 7. All right, let's see what we can do next. Next we have, pause the video here, and you guys find g of negative 1 plus f of 3. All right, well, we actually found both of these. We found g of negative 1. We found f of 3. So g of negative 1 was negative 7. F of 3 was 10. Then when I add negative 7 and positive 10 together, I get 3. So g of 1 plus f of 3 is 3. Now, what do the harder problems look like? Well, let's look at this. We have f of g of 2. Well, we're going to kind of work from inside out. We're going to find the value of g of 2, and once we find g of 2, then we can substitute that amount in to the f equation, or the f function. So first, to find g of 2, I want to use this expression, and I want to replace the x with 2. So I'm going to have 2 times 2 is 4, plus 4 is 8, so g of 2 is 8. Now I can replace this area that says g of 2. I can put 8 there, go to the f function, and replace 8 with x. So f of 8 would be 3 times 8 plus 1. 3 times 8 is 24, plus 1 is 25. So f of g of 2 is 25. So here is a little hint for you. F of x is the same as y. So remember, before we started using f of x, we'd used y for many years, right? So if it helps you to think of f of x as the same as y, particularly for graphing purposes, it is the same. F of x is the same as y. So like f of x equals 5x plus 1, we could think of that in slope-intercept form like y equals 5x plus 1. And I hope that helps you guys get started with function notation. Have a great day. OUT spells out.